Good afternoon, everyone. Today, we'll discuss about the fundamental of cloud computing. In my last lecture, we have discussed about uh, other paradigm other computing paradigm like grid computing, cluster computing, utility computing, parallel computing, and distributed computing. Today, we'll see the details about the cloud computing. Okay, so last class we have seen the definition uh, given by US National Institute of Standard and Technology, which is called as NIST. So they have defined the cloud computing is a model for enabling ubiquitous, convenient, on-demand network access to a shared pool of configuring computing resources, and it may be any form of the resources such as network, server, storage and application and services that can be rapidly provisioned and released with minimal management effort or service provider interactions. So this definition is proposed by US NIST, but if you go through different books and different sites, you will find different definitions related to cloud computing, right? So this definition we have already discussed that cloud computing resources you can access from anywhere in the world, right? And you can use any devices to use the cloud services. It is not limited to only the PCs, workstations, and supercomputers. So I also told you about NIST suggested 5 different essential characteristics. So we will discuss that one first, 5 different characteristics. Then we'll see 3 different type of services, and then we'll discuss about 4 deployment models. Okay, so these characteristic services and deployment models are given by NIST. But if you go for other articles and other books, you may find more characteristics or more deployment model or more services. So let us discuss one by one. Let us start with the characteristics. So there are 5 different characteristics is defined by NIST. The first one is our on-demand self-service. Second one is broad network access. Third one is resource pooling. Next is fourth one is our major service. Fifth one is called as rapid elasticity. These 5 characteristics are mentioned in the document by NIST. So let us understand each and every characteristics in detail. On demand means you can access to the services at any point of time. On demand means it may be whether it is night 2 or it is morning 6 or it may be any time. Okay, you can make a request for the services. And these services are provided as a self-service. Okay, you have to create your account, you have to access the site, and you have to see the varieties of services, and you have to select the services, and you have to use that particular services. There is no person is going to help you to get that particular service. Although last class I also told you that a broker can help you, right? But broker is acting on behalf of the user. So as a user, you can get these services by your own if you have a little knowledge of how to operate a particular site, and at any point of time you can access these resources. So a consumer can unilaterally provision computing capabilities such as we can say server time, we can say network, or we can say storage is needed automatically without requiring of human interactions with each service provider. Like you can take an example of Gmail, right? So in Gmail, you have a username, you have your own password. Your username is known to public, but password is known to you only, right? So with this username and password, you can connect to your email box, which is provided by Google, which require no human interactions. In order to access your email, there is no need of any human, right? Also, not only Gmail is providing services, many people are also using Reddit Mail, many people are using Hotmail and other email IDs, right? These are also the cloud services which you will get without any human interactions. It will be provided you automatically. Only you have to remember the username and password in order to view your emails. So whatever service provided by your provider, right? Whether it is a email service or whether it is a infrastructure related service or software related service, that you can get without any interactions. You need not worry about that whether you can say that whenever you are using the resources, right? Nobody is going to assist you. You also you have a help and support, but there is no human intervention between a user and a cloud service provider, right? That's why it is called as on-demand self-service. Any service you can ask for without any without taking help of any other, right? Just a very little knowledge is required to access the services. The second one is called as your broad network access. So broad network access says that any device that you can use for getting these particular services. So capabilities are available over the network and access through standard mechanism that promote use by heterogeneous thin or thick client platforms. Like you can use your mobile phone to access, you can use tablet, you can use laptop, or you can use workstations. So what we are looking for these devices, you have to note that these devices should be connected to the internet. So our primary requirement to use the services is internet. So any device where you have internet, you can simply use these services by using that particular device. It is not limited that there is no minimum capability device mentioned for the cloud computing. That minimum requirement is not there. Minimum requirement is you can say that is internet. If you have a 256 GB of 256 MB of RAM, then also you can access to the cloud services. If you have 4 GB of RAM, also you can access to the cloud services. So there is no minimum line mentioned for the cloud computing, but make sure that your device is connected to internet. And here we are considering thin and thick client platform. Can anybody tell what is the difference between thin and thick? What is the difference? Can anybody guess about thin and thick client platform? Am I audible? Yeah, can anybody tell about thin and thick platform? So here you can see thin and thick is based upon you can say the responsibility taken by a particular client, right? So sometimes a client is not able to you can say incapable to handle some of the responsibility. So that will be handled by the server. Okay, sometimes client is more capable, right? Client is capable to, you can say, to take some features, some take some responsibilities, right? So when client is incapable, we call that client as a thin client because the minimum responsibility is given to thin client and maximum responsibility given to the server. But when your client is capable to do this thing, right? Client can do some uh, take some responsibility, can do some work. At that time, we consider that as a thick client, right? So when we consider thin client, so on the other hand, we are taking a thick server. Okay, so that if client is not taking the responsibility, the server has to take that responsibility. On the other hand, if you have a thick client, so on the other hand, you can take a thin server, right? So in this way, you can make a pair, and obviously they are heterogeneous, they are not safe. So the main idea behind this broad network access is that you can access any, you can use any devices to access the cloud services. Now coming to the next one, resource pooling. I told you a large pool of resources are there. This pool of resources may contain computing power, or this pool of resources contain, uh, you can say, storage, right? So you can ask the resources from this particular pool. So the provider computing resources are pooled to serve multiple consumers. And a very large variety of customers are there, starting from a minimum requirement to a maximum requirement. So they are using a multi-tenant model with different physical and virtual resources, dynamically assigned and reassigned according to the consumer demand. Right? Like a X company request for 5 servers today, right? Then it has dynamically changed his requirement to 10 servers. So from the pool, earlier it is using only 5 servers, but now it is using 10 different servers. Later point of time, suppose X again wants to use 7 servers, then also it can be modified, right? Similarly, you can see this. This is not like, no, this is just like a mapping between the virtual resources and physical resources. Because from the user perspective, if you see, these are nothing but the virtual resources. Okay, user side it is treated as a virtual resources. But if you see CSP side, cloud service provider side, so this can be considered as a physical resources, right? So basically, what we are doing, we are mapping between these virtual resources and physical resources, and the resources is provided from this particular pool. Whether you need storage, suppose you need a storage of 5 GB, or you need 5 virtual CPUs, right? Whatever may be the requirement, that will be provided from this resource pool. And different client has different requirement. All these requirement will be fulfilled by this resource pool, right? That's why we call this resource pool as a infinite resource hub, right? So any amount of resources you can ask to this resource pool. Okay, coming to the next cloud characteristics, that is called as measured services. Measured services, that how you are going to calculate how much unit of services is used by a particular client, right? Just like I told you about mobile towers, right? The mobile providers. In mobile provider case, we have seen they are charging some amount for 84 days, right? Or earlier they are charging some amount per minute basis or per second basis. Similarly, here in the measured services, what they are going to do, there is some metering concept, like per unit basis or subscription basis or a flat rate basis. Different type of units are there. User can choose one of the measured services for accounting purpose, right? So cloud systems automatically control and optimize the resource use by leveraging a metering capability. Okay? This is metering capability at some level of abstraction appropriate to the type of services. So the services may be the storage, the services may be the processing, maybe bandwidth, maybe any other thing. So user has to log in into the system and use the resources. Based upon the metering capability, it has to count the services. Like you use the services for, let's say, 150 seconds, right? Another services, suppose you use for 70 seconds. So if it is a metered services is with respect to second, so I can calculate it is a 220 second. But I am calculating, let's say, metered services per minute basis. So 150 seconds can be considered as 3 minutes, right? 70 seconds can be considered as 2 minutes, right? So total you have used 5 minutes of the services. So based upon the agreement between the user and the provider, you have to decide what is the metering capability. Okay, so you have to, based upon the agreement, the amount will be calculated. For example, I want to calculate some amount, let's say dollar 0.02 per CPU per hour. So that you have to pay. Or here I can say dollar 1 per CPU per minute, something like that. Minute or second or something like that. You can like here you can tell second, not minute, not hour, right? So this pricing scheme you can apply here, and this particular scheme for minute plan you can apply this particular plan, right? So resource uses can be monitored, it is controlled and reported, and providing transparency to both provider and consumer of the utilized services. At any point of time, if you want to know how many units you have used, what is your free quota, how whether you have exceeded the free quota or not, that you can get the information from the resource usage option, right? If you go to AWS, Amazon Web Service, you will see if you go to your account, there is an option account. There you will get all the details information. Your usage in the last 30 days, how much amount you have paid in the last month, all the details you will get in that section. So that's why it is called measured services, right? Now, similarly, if you go for the last cloud characteristics as mentioned by NIST, that is called as rapid elasticity. Okay, elasticity or scalability, sometimes we also say. It means you can go for scale up or you can go for scale down. Okay, either scale up or scale down. So capabilities can be elastically provisioned and released, in some cases automatically. Sometimes human intervention is required to increase it. Sometimes this process is also done automatically. To scale rapidly outward and inward commensurate with the demand. So whether you will increase your resource or decrease your resource is purely depends upon the demand. And demand is always in fluctuate in nature, right? It is fluctuate. Okay, like this, just like you can see, this is also a demand curve. You can see sometimes it is increasing, sometimes it is decreasing. Similarly, look into e-commerce sites when there is a sale is conducted, right? Great Indian sale, or you can say big billion day sale. So at that time, suddenly the number of users are increasing, right? But once that sale is over, then it is again decreasing. So whether you will go for outward or inward, okay, in the process of scaling, that purely depends upon the demand. And to the consumer, the capabilities available for provisioning often appear to be unlimited. Up to when you can increase, that is not mentioned. Like increase from 2 servers to the 5 servers to the 100 servers to the 10, 1000 servers. You may be interested to know what is the last limit, right? What is the highest limit? So there is no such limit. That's why we call this as a unlimited, and can be appropriated in any quantity at any time. Right? So in order to increase this to a very large number, again, cloud service provider has maintained their infrastructure. It is excelling, sometimes they are creating more infrastructure. There are several data centers are there. One data center can carry resources from another data center. In that manner, we say it is unlimited resources. Okay, so these are the 5 different characteristics mentioned by US NIST, which we have discussed, starting from on-demand self-service. Second one is broad network access. Third one is resource pooling. Fourth one is measured services. Fifth one is rapid elasticity. But as I mentioned, if you study different materials, different books, you will find more characteristics, not limited to these 5 characteristics. So let us see some of such characteristics. So these characteristics also reported in various people, okay, various researcher. One is called as massive scale. You can say massive scale means it is a very large scale, right? So we are saying resource pooling. Resource pooling is also having a large amount of computational power, large amount of storage, right? That is also a massive scale. So you can say resources are in massive scale. Resource may be anything, right? Like we say processor, it may be processor or CPU, it may be storage, it may be network. Many people define that as a massive scale. Next one is called as resilient computing. Right? Resilience means you can say even if there is any fault occur in the system, it is resilient, right? It is not affecting the system. Like if you go for a peer-to-peer network where there is no single point of failure, okay, or distributed computing network. One of the examples is a peer-to-peer network, right? So if you go for such network, even if a node is failed, it is not going to uh, affect the whole performance of the system, right? Similarly, we have homogeneity, right? We have heterogeneity also, homogeneity as well as heterogeneity. It may be similar architecture, it may be different architectures. You may consider the system as a homogeneous one, or you may consider it is a heterogeneous one. Both types of characteristics available in cloud. Another is geographical distribution. Right? They are not located in a single place. Again, the same concept of distributed computing. Like if you go for internet, right? Till the birth of internet to till date, we have not encountered any failure. Why it is happened? Why it is happened till now? There is no failure. Do you think there is no failure in the system? Even if there is a failure in the system, it is not known to the user. Because you can say one server may be located in our country, another may be located at US, another may be located at UAE, another may be located at Singapore, like that, right? So when a particular server is failed due to some issue, maybe some internal failure is there, or you can say the failure is due to uh, you can say any natural calamity also, then the request is again redirected to other servers, right? So instead of getting the services from this particular server, the user gets services from another server. So like that, they have connected in such a manner that even if there is a failure happen, it is not going to impact others. That's why we call in internet space it is an internet distributed system, which is geographically distributed over the world. That is also one of the characteristics. I already told you about the virtualization. It is a very popular technique in which multiple users can access the resources of the physical machine by creating virtual machines. And many people also define virtualization is one of the characteristics. There is another background technology which is called as service-oriented architecture. It is called as SOA, right? The service-oriented architecture is a very popular architecture that is used in the cloud, where we consider each and every service as a web service, right? It may be WS with respect to any type of services. We can say WS hyphen star. Star may be related to any type of services. Similarly, the cost of the software is also very low. Like purchasing a particular software is not easy, right? If you see the cost of a software is very high, right? But if the same software is provided by your cloud service provider, so suppose you have subscribed to per hour basis. Suppose per hour basis you have subscribed to your service. Imagine your final year project. In final year project, you need some resources or some software. Purchasing the software is very difficult because it is a high cost. But if any cloud service provider provides you per hour basis, okay, let's say rupees 10 per hour. Suppose you need for 50 hours of 50 hours you want to use that particular server. So 50 into 10 you have to pay. So it is a very nominal amount in comparison to the cost of a software, right? That's why the cost of the software is low. Security is also an issue, also a challenging task for cloud computing. So many people are also working in the security area. They have proposed many lightweight solutions which can make the cloud environment secure. So the data should not be revealed, right? The data which is stored in the data center, they should not be revealed to unauthorized person. So that comes under the advanced security. So like that, this is not the complete list. Just I'm giving you a brief one. But if you go to the literature, you will find the number of characteristics people say. Okay, but we restrict us to five different characteristics which we discussed in today's class. Okay, any question till now related to characteristics? Any question, anyone? Okay, so the next one we'll see, that is called as the service model. So sometimes people call service model as the types of cloud. So based upon the services provided by cloud computing, we mentioned that there are three different types of services. One is called as a software as a service. It is its acronym is SaaS, and there is another type of service that is called as IaaS, which is called as infrastructure as a service, and another type of service that is called as platform as a service. Okay, sometimes people call this is a SPI framework. What is the full form of SPI? Can anybody guess? What is the full form of SPI? S is software, P is platform, I is your infrastructure, right? So sometimes we refer it is a by SPI framework, or we call three different type of service, which is called software as a service, infrastructure as a service, and platform as a service. To better illustrate you, let us show you a non-technical example related to the cloud service model. Then you can map what kind of work is done in the cloud, right? So I request all of you to go to Google and open your smartphone, and you can type PIJA as a service model. Okay, you can go to this particular diagram. This will give you the details related to the different type of service. Okay, all of you copy this one and search this one. Okay, see this diagram. This will give you a non-technical example which you can map later to our services, right? Like here, you can see there are four different columns we have. In the first column, we are talking about traditional on-premises. Traditional on-premises means, suppose you have a company. In your company, you have servers. So you are maintaining your own servers, right? The maintenance, the testing, each and everything related to that particular server is done in your organization only. So it is called as a legacy system, old system. Old system case, people used to maintain their own infrastructure. Any security policy you want to enforce, any work you want to do, you can do in your own infrastructure. They don't want to move to the cloud. Okay, just like whatever task you are doing in your home is can be considered as a traditional service. Like here, they have explained nicely about how to prepare a pizza, right? You can see pizza as a service means how to prepare a pizza, that is given in this picture. So if you want to prepare at home, and if you consider traditional on-premises, you have to go to market and you have to purchase the things that is required to prepare a pizza. Like you can see cheese, toppings, and tomato sauce, pizza dough is required. These are, you can say, ingredients to prepare the pizza. Once you have the ingredients that these pizza, for pizza, then either you need fire, you may say gas, you may say any electric stoves or something like that. Okay, through which you can prepare the pizza. And oven is also used to for pizza, right? So these are nothing but providing a platform to prepare the pizza. or you can say electric connection or gas connection is also required for pizza. But once pizza is ready, then you need drinking uh, any drinking soft drinks, or you can say drinking dining tables to serve the pizza, okay, with some cold drinks, right? So you require these many things if you want to start a business, let's say pizza as a service. Then you have to prepare this thing, and each and everything you can maintain in your home, right? You can prepare these things in your home and sell the pizza. But here you can see that the same responsibility is divided into three different parts. One is called as the infrastructure, another is called as platform, another is called as software as a service. Like here you can see, first one, if you go to infrastructure, infrastructure is related to what are the ingredients required to prepare the pizza. So you can see the last four, pizza dough and tomato sauce and toppings and cheese. These are required. These are the essential things to prepare a pizza, right? So if you need this thing, then you can say you require infrastructure, right? So suppose somebody is already having this one, so he don't need, he or she do not require the infrastructure, rather than he require the platform. Platform, you can say it is a environment in which you can prepare the pizza once you are ready with the ingredients, which is nothing but electric gas, or you can say electric or gas, or you can say oven, or you can say fire. Okay, that is also that these are coming under the platform as a service. Suppose you are also done with this one. Now you need only the software. Software means you require dining table and soft drinks, right, to serve the pizza, right? So here you can see, if you see each and every individual column, earlier in traditional on-premise system, the entire thing is done by you, right? Starting from ingredients to final product, that is pizza, right? Preparation of this pizza, everything is done uh, by the traditional systems, right? But when you go for infrastructure, you can see you can manage the rest of the thing. Like here, you can manage dining table, drink, electric gas, oven, and fire. But this pizza ingredients will be provided by your vendor. Vendor is providing you an infrastructure, but you have your platform as well as software. Similarly, if you go for second one, that is platform as a service, here you can see your vendor manages the infrastructure as well as platform, but you manages what? You manages the software part, right? Platform is also provided by your cloud service provider, right? Like some people, like if you see one of the example, I will tell you, while you are traveling, uh, nowadays we have food delivery at a train, right? There is many applications are there through IRCTC. So suppose you will book a particular meal, right? Then the meal will be delivered to your designated station, right? Suppose you have picked a particular location. When your train reaches to that particular location, what you will do? The item is going to deliver to you, right? So basically, what happens? There is a something called as cloud kitchen, right? People are not having their own kitchen, but they are collecting from various sources and delivering the food. So in that case, they are not bothered about where these ingredients are collected, how they prepare this one, rather than they focus on how to deliver this to the customer. So in that case, platform as a service will help. Now, if you go for software as a service, each and everything, whether it is infrastructure, platform, and software, will be provided by your cloud service provider. But uh, the user has no role. User has a very, very minimum role, or you can say thin role. The major role is given to the cloud service provider. So in this way, three different services we have, that is infrastructure as a service, platform as a service, and software as a service. Is it clear? This overall picture is clear. Any question related to this?
Sir, can we say that in all the three, the major difference lies in the flexibility which it provides to the user?
Major difference is
Means a software as a service provides much more functionality than platform as a service and infrastructure as a service.
Exactly. So here you can see either your provider is responsible for infrastructure or infrastructure platform or infrastructure platform and software, right? You decide whether you can handle platform software or you can handle only the software, right? Based upon that, you can decide whether to go for infrastructure as a service, platform as a service, or software as a service. Because infrastructure plays a very important role. It is the primary role. Is it okay? Okay. So let us discuss about one by one in much more details. Software as a service. We are using a lot of services in our day-to-day life, which are the examples of software as a service. Like Google Spreadsheet is an example. You are using Instagram is also an example of a software as a service. Facebook is also considered as a Facebook is considered as a software as a service. You are using Gmail. Gmail is also considered as a software as a service. So here the capability provided to the consumer is to use the provider's applications. Provider has given a Gmail application and Facebook application, WhatsApp application. These are represented in the form of an application, right? And these applications are running where? In the cloud infrastructure. Okay. And user has to create one account, right? In that particular infrastructure or environment and can use the services. That's why the applications are accessible from various client devices. Either it is a thin client interface like a web browser. You can use Internet Explorer, Mozilla Firefox, Google Chrome, Opera Mini, whatever may be the web browser or a program interface. So client side it is very less, right? In each and every system we have a browser. Like if you purchase a small handset also, that handset is having a browser. That browser is sufficient to use the cloud services, right? So that's why we call this is a thin client interface. But when the requirement is more from the user perspective, let's say in some other case, then you can say that is a thick client interface. But cloud case, thin client interface is sufficient. And here consumer does not manage or control the underlying cloud infrastructure. In order to use this application, you need not install a specific software or you do not require a specific hardware. So consumer does not manage and control underlying cloud infrastructure, including the network, server, operating system, storage, even individual application capability, with the possible exceptions of a limited user-specific application configuration and setting. Okay, a minimum requirement is there, but not the major requirement. The minimum requirement is also satisfied by each and every devices. Like you can say Java is required for all type of applications, right? JDK is required. These are the minimum things that is a requirement and which is there in each and every system. So that's why software as a service is a very popular paradigm. Many cloud service providers offers software as a service. Now come to the next one that is called as cloud infrastructure as a service. Like if you go for Amazon Web Service, two popular infrastructure as a service is called as EC2, that is called as Elastic Compute Cloud. Elastic Compute Cloud. Another one is called as S3, that is called as Simple Storage Service. Okay, so these are the you can say services. There are a lot of services are there under AWS, but these are the two popular services you can say under the infrastructure as a service. So the capability provided to provision processing. Processing is done by Amazon EC2. Storage is done by Amazon S3. Network, there is another services called Route 53. Okay, if you go to Amazon service, you can find where you can get, you can host a static website also, and other fundamental computing resources are required. And consumer can deploy and run arbitrary software. Here, consumer can deploy and run any type of software. So examples are AWS and FlexiScale is another cloud service provider which provides the infrastructure as a service. And you can see infrastructure as a service is a very popular in comparison to other type of services, because you have seen in that example, infrastructure is required for all types of services. If you go for platform, you have to assure infrastructure is there. If you go for software as a service, you have to assure that infrastructure as a service is there. Now coming to the third type of service, that is called as platform as a service. Here, the capability provided to the consumer is to deploy onto the cloud infrastructure. Consumer created or acquired application created using a programming environment, okay, or libraries or services or tools supported by the provider. For example, you can see our operating system. Operating system is a platform, right, which interact with the user as well as computer, hardware and software, right? So operating system is providing you a platform to install a particular application. Like you can see MS Office is also an application, or you can say software. We want to install MS Office in our system, right? So who is enabling us to install this particular software? Our operating system. So operating system itself is a software, right, which we say is a system software. But when you go for MS Office, we call that is a application software. So in order to deploy any kind of consumer applications, you require some programming framework, you require APIs, application programming interface, you require library services that will be provided you by platform as a service. Platform means basically it is a runtime environment. Okay, it is providing you a runtime environment to do that one. So here also consumer does not manage the underlying cloud infrastructure. Consumer does not manage network, servers, operating systems, storage, but they have control over the deployed application, possibly configuration settings for application hosting environment. So if you go for previous system like legacy system, if you go in legacy system, customer has to concentrate on how to write, focus on the logic part of a particular application, and also focus on how to integrate some feature. Customer is also interested, also responsible to deploy that application, manage that particular application. But if you go for cloud, you have to only focus on the logic part. You need not bother about this deployment and management part. It will be taken care by your cloud service provider. So this is some examples of your platform as a service, right? And you can search also who are the providers for IaaS, who are the providers for platform as a service and software as a service, so that you can figure out that what are the services uh, comes under IaaS, PaaS, and SaaS, right? So try to go through the online sources to find these things, so you have a clear idea about it. Now, if you want to represent these three different service model in a single go, here you can see this is the picture. So always remember, if you go for any type of architecture, always the bottom architectures are more or less they are hardware architectures, right? They are having hardwares components, right? But when you go for upper layers, they are having software, right? So the bottom layer is infrastructure as a service. Okay. On top of IaaS, you have a platform as a service. On top of PaaS, you have a software as a service. Okay. And client is on top of all the services. That's why I told you software is close to the client, right? Hardware is close to the cloud service provider. So how a particular cloud consumer access to these particular services? Through web browser, or through a well-defined mobile application, through a thin client, or through a terminal, or through a emulator, right? You can type a particular website, okay, or you can create an account in a particular application and get the services, right? Now, what comes under SAS? Under SAS, you have customer relationship management. You have our email system. I already mentioned Gmails come under software as a service. Virtual desktop, communication, and games. These all are coming under the software as a service, where you have to simply just like a plugin. You are doing plugin and you are working with that. Okay, you need not require to set up the whole infrastructure. Coming to platform as a service, we need a runtime environment that we call as execution runtime. You need databases, you need web servers, you need development tools. Okay. Similarly, infrastructure as a service case, you need virtual machines, which are part of your physical machines, and servers, storage, a load balancer, and network. Load balancer is used to manage the traffic, and you are using the servers to create the virtual machines. By taking the resources of the servers, that is which we call as physical machine, we are creating multiple virtual machines, right? So here you can see the responsibility of different service model, but later people come up with different type of services. They come, somebody come with sensor, right? Nowadays people talk about IoT, Internet of Things. They focus on the sensor. So they called as a sensor as a service. Okay. Later point of time, people come up with some solution related to the healthcare, right? They called as a healthcare as a service, right? Some people come with a database, they call as a database as a service. Okay, like that you can see they treat everything as a service. Okay, they consider new terms and call that as a service, like business process as a service, storage as a service, security. One of the important part is security. Security as a service, backup as a service, desktop as a service. So we represent these all services in the form of XaaS. So primarily we have three different type of services. One is IaaS, another is PaaS, another is SaaS. But overally we call that is XaaS, which is everything as a service or anything as a service. Okay, anything can be treated as a service, or everything which comes to your mind can be treated as a service. So later we represent this one, that is XaaS, to represent all type of services. Okay. Now coming to the next part, is there any question up to this? Okay. So now come to the last part. It is called as the division of cloud or different types of cloud with respect to the deployment. So if somebody will ask you what are the different types of cloud, you can say cloud can be defined in different types based on deployment model and based upon the service model. Service model we already discussed, that is IaaS, PaaS, and SaaS, or you can say XaaS, everything or anything as a service. But when you go for a deployment, so the different types of clouds are defined under the deployment mode. Based upon some characteristics, you can make a division, right? So here the characteristics is considered as deployment. Deployment means location, okay, or you can consider service, right? So if you look into the deployment part, there are four different types of cloud. One is called as private cloud. Second one is called as community cloud. Third one is called as public cloud. Fourth one is called as your hybrid cloud. Okay. So you are given with one institute email ID, right? Right. Some at NIT and suppose in our institute we are given with NITW. Okay. Some institute are given suppose NIT MJ, right? Something like that, right? So the type of services you are getting your normal Gmail, more or less the services is same in this particular email ID. Can anybody tell what kind of extra services you are getting in these email IDs in comparison to Gmail? What is the difference actually between these two type of email services? What is the difference if you compare with the Gmail, right? You have a Gmail ID, also you have a your install email ID, right? What is the basic difference between these two email ID? What is the difference we are getting in these two email ID? Can anybody say? So you can find more or less they are same, right? More or less they are same. You can see Gmail case, the Google services, including the emails, that is restricted to 15 GB. But when you go for your institutional email ID, it is not restricted to 15 GB. You can accept that, right? This is one only the difference between a normal service and a specified service. One more difference is you can say anybody can create one account in the Gmail. Okay, any person who is there in this world can create an account in the Gmail in Google service, right? He or she can create a Gmail service, right? But if you go for a particular organization, only the people associated with that organization, let it be, maybe they are students, maybe they are stakeholders, maybe their parents, maybe their alumni, maybe the faculty members, maybe staffs, they only can create the respective email ID. No outsider is going to be provided with a specific email ID. Okay, that is also one of the difference between public and private cloud. Okay, public services and private services, right? Here you can say this is just like a service provided to public, right? But this is not the services that is provided to the public, right? So now let us discuss. If you go for private cloud, the first type of deployment model. Here the cloud infrastructure is operated solely for an organization. It is limited to a particular organization. So if anybody belongs to that particular organization, then that person can create one email ID in that domain. Other persons are not allowed to that particular uh, those who are not related to that particular organization, they cannot create. Other people are not allowed to do that one. So one of the example you can say our Windows Server Hyper-V is an example of our private cloud. But private cloud is again of two types. One is called as on-premises private cloud. On-premises private cloud. Another is called as off-premises private cloud. So sometimes what happen, like if you see, as I mentioned, our email system, more or less these are the system, these are the email IDs provided by Google only, but it is restricted to a particular institute. Let it be NIT Warangal or NIT Mizoram or any other institute, right? So it is restricted to that particular organization. But if you see, this particular system is maintained by that organization only, right? It is maintained by that it is meant for that particular organization, but you can say maintenance other parts are taken care by Google, right? So you can see the email server which provides you the services, they are not present in your institute, right? They are a part of Google only, Google server only, but that is restricted to your organization. So in that case, we call that one as a off premises, because the servers are not with us, but still it is a private cloud. Nobody can create a private cloud. Okay, nobody can access to your private cloud, but these are not maintained by your institute or organization. But when you go for on premises, these everything, the servers, maintenance, everything is managed inside the boundary of that particular organization. If it is within the boundary, we call that as on premises. If it is outside that, we call it as off premises. Like in campus placement also, we generally say that on campus and off campus, right? On campus means we have to go out. On campus means that is within the institute. So private cloud can be provided in on-premises mode and off-premises mode. Most of the private cloud is off-premises mode because they are not belongs to the servers are, or everything is not belongs to that particular organization. Only there is a admin login is provided to that particular organization in the case of email system. And from admin portal, you are able to create one email ID, delete one email ID, manage the email IDs. Right? So it is an example of a private cloud, whether it is off premises or on premises. We call that private cloud. Similarly, the second one you can see that is called as public cloud. So here the cloud infrastructure is made available to general public. Anybody can create and use that particular service. Like Google Docs we are using. Sometimes we are sharing these documents with multiple people and multiple people can access to that particular document. So that is a public use, right? Spreadsheet is another example of your public cloud, which is available to public. Not only email system, a lot many services are there that is only for public use, like social media, you can say, or e-commerce sites. These all are open to all, right? Anybody can create and create and do any type of things in the system, right? They are whatever the features available, they can utilize that particular features. That's why we call that as a public cloud. There is another cloud that is called as community cloud. So if a particular company X has multiple branches in different places of a particular country, and they want to these branches wants to collaborate each other to perform a particular task, then we call that as a community cloud, right? So these all branches are belongs to the company X, right? But they are not placed in a single location. Or sometimes multiple organizations join together execute a particular work. That is called as also community cloud because their goal is same. They are solving for a common goal. That's why it is called as community cloud. One of the example you can see, suppose if you go for any multinational company, you may find one branch at New Delhi, another branch is maybe at Kolkata, another maybe at Hyderabad, okay, another maybe you can say at Mumbai, some location like that. But whenever you go for the development process, all are combined together or collaborate together to solve that particular common goal. So we call that as a community cloud. So here the cloud infrastructure is shared by several organizations to support a specific goal. In that case, you can go for community cloud. And the last one, which is called as hybrid cloud. And you know hybrid means it is the combination of any two cloud. Okay, you can combine any two or more clouds in order to build the hybrid cloud. So the cloud infrastructure is composition of any two cloud. It may be public, private, it may be public community, or it may be private and a community. So that comes under our hybrid cloud. And most of the collaborations, you can say either it is done in the community cloud or it is done in the hybrid cloud. So cloud bursting for load balancing between clouds. So cloud bursting is one of the example of hybrid cloud, which is used for load balancing between the cloud. So if a, for example, let us consider a particular cloud service provider, another cloud service provider, right? So when the load is exceeded in this particular cloud service provider, what this cloud service provider has to do, it has to migrate, transfer some of the loads to cloud service provider 2. Similarly, when CSP also exceeds some limit, so it has to collaborate with CSP1 to provide the services. Okay, that is called as load balancing between clouds. Yes. Generally, it happens between two different data centers, which are handled by the same cloud service provider. But we assume that in future of the cloud computing, multiple cloud service provider also needs to collaborate to provide the services. Right? In that case, we can go for hybrid cloud because multiple providers are there. They are providing you different type of services. So in that case, hybrid cloud services provider is much more helpful. Okay, if you have any question, you can ask. Yeah, Ronak, you do you have any question related to public and private? Ronak?
No, sir.
Ah, okay. Anyone having any question? Okay, so we'll stop for 5 to 10 minutes. We'll start it again 4:10. Okay, we'll resume. We'll continue our discussion at 4:10 onwards. Okay. My screen is visible?
Yes, sir.
Okay. So let us continue our discussion. So now we'll learn another important technology that is called as virtualization. Also, you have seen that virtualization is mentioned as one of the common characteristics of cloud computing, but we'll see detailed about various virtualization technique. So, actual environment is there in the cloud service provider end, and virtual environment is there in the provider end. Like we are using Google email, right? But we don't know where that emails are stored, who is managing these emails. And in fact, these emails are not stored in our computer system or mobile phones or tablet or any device that you are using to use your email service. So that's why we call that as a virtual workspace or virtual environment. So here it is this virtual workspace is actually providing an abstraction of an execution environment that can be made dynamically available to authorized client by using a well-defined protocol. So whenever you require your service, that will be provided to you because you are an authorized client for that particular service. And this process is well defined through some protocols that is having some rules and regulations. So by the help of that, we are able to access the services irrespective of the device and irrespective of the location. But here you can see there is also a resource quota. Resource quota is defined with respect to CPU, memory, okay, like whether you require two virtual CPUs or four virtual CPUs based upon your type of services you have obtained, that is restricted, right? You cannot exceed that one. Like if you go for Amazon instances, we call also Amazon EC2 instances, Elastic Compute Cloud instances. There you will see the number of virtual CPUs are restricted for each and every type of instances, right? So if you need a higher instance, then you have to move from one instance to another instance so that you will get more quota for a particular resources. Similarly, software configurations, these also contains your operating system, is also maintained by your provider, not by the user. Now, let us see this diagram. This will give you the overall idea of how actually the virtualization technology works. So if you see the bottom part of this particular diagram, in the bottom part we have hardware. Right? This hardware is may be considered as a servers or set of servers. Hardware may be considered as a you can say it is a data center also in a long scale, right? Hardware may be considered as a PCs, workstation, anything, right? So on top of hardware, we have hypervisor. Hypervisor is also called as virtual machine monitor, also called as VMM. So what is the responsibility of this hypervisor? Actually, hypervisor creates the virtual machine. If you want to create a virtual machine, you can create by the help of the hypervisor. Like how many of you are aware of VMware? Can anybody respond? If you have used VMware, have you used VMware in your system?
Yes, sir.
Yes. So VMware is an example of your hypervisor because through VMware you are using the virtual machine. So if you go for a normal computer systems, right? That systems are having two different operating systems. So when we switch on our computer system, it is asking us to either go for Windows or go for the Linux operating system, right? Windows or you can go for Linux operating system. So user has to choose one of the operating system as a default operating system, or based upon the last use also you can select, and user can select one of these operating system to load the operating system in your computer system. So in this context, you can say Windows is also your host operating system. Linux is also your host operating system. Neither Windows is dependent on Linux or Linux is dependent on Windows operating system. Okay. But you can say in Linux and Windows case also, you can see the space given by the Linux system is not given to the space to the Windows system, or vice versa is also true. The space occupied by Windows system is not captured by Linux. Linux amount of space captured is not captured by your Windows system, right? So both are actually host operating system. But what happens if a user is willing to go for only one operating system? Let it be Windows operating system. You have installed Windows operating system in your computer system, and in your system you have installed VMware, right, which is a hypervisor, or we can say virtual machine monitor. Through this hypervisor, you have installed another operating system, that is called Linux operating system. So in this case, if you see, this Windows operating system is your host operating system, but Linux is not your host operating system. The main reason why it is not a host operating system is that Linux is installed on top of the Windows system. So the space taken by the Linux is a part of Windows system. Here you have a partition, right? But here there is no partition. Linux can be directly taking the space of the Windows, some space of the Windows. That's why we call this one as a guest operating system. Okay. Previous case, you can see in the first scenario, both are treated as a host operating system, but now one of the operating system is called as host operating system, another is called as guest operating system. So if you go for this concept of virtualization enable us to create the different virtual machines on top of the hypervisor. And you will surprised to know that this host operating system is also optional. No need to create your host operating system to create the guest operating system. But in our system we do. But when you go for the cloud scenarios, you will see without a host operating system also you can create a guest operating system. Right? Like here you can see on top of hypervisor, you have 3 operating systems. These operating systems are nothing but your guest operating system. Right? Or you can treat these 3 are the 3 different virtual machines. Right? And each and every virtual machine is having an operating system. They may not be the same operating system. They may be having different operating system. And we are executing one application on each and every operating system. The application executed in this operating system may be different from other application which is executed in another operating system. The main purpose of this hypervisor, VMM, virtual machine monitor, or you can say um, our VMware, is that you have to create virtual machines, right? Or you create an operating system on top of another operating system. So if you go for implementation of on this virtual machine, so it is nothing but the abstraction of the physical host machine. Like in computer organization also, you have studied about virtual memory, right? Virtual memory is a concept, right? Which is taking the resources of or the memory of the physical memory. Okay, if the physical memory size is small, then virtual memory size is also small. In fact, there is no virtual memory, right? We are creating a concept, right? To you can say that to provide the user that as big as program the user can write, subjected to the size of a physical memory. Similarly, here what we are doing, we are making abstraction of the physical host machine. So hypervisor intercept and emulates instructions from virtual machine, allow management of the virtual machine. Some of the examples are VMware is one of the example. Other examples are called as XCM, KVM. These all are examples of virtual machines, right? So the main purpose of any type of virtual machine is to manage the virtual machine or create the virtual machine, monitor the virtual machine, and in fact, through hypervisor, you can destroy the virtual machine as well. So basically, we are doing this hypervisor emulates the instructions, right? Similarly, you can see there is a plugin hardware or support structures are also there, which provide infrastructure APIs, right? Like here you can see the support infrastructure is our hardware. which belongs to a physical machine, right? But by using the hardware of the physical machine, these three different machines are taking the resources of the part of the hardware to build different machines. Like if you say this, but these virtual machines are different, belongs to different user. So what happen? Three different users can simultaneously use this particular hardware, right? Rather the single particular user or single user, individual user. Here there are three different individual users, three different users. So definitely your hardware utilization is going to be increased when you go for the concept of virtualization. Similarly, here you can see the detailed view of virtual machine, right? So obviously the bottom one is your hardware. Then you can see we have virtual machine monitor, that is VMM or hypervisor. Then on top of hypervisor, you have three different virtual machines. Okay, we have three different virtual machines here. First virtual machine, you have installed one guest operating system, let it be the Linux operating system. Second, the virtual machine, you have installed another operating system, that is, let's say, Net BSD operating system. Third one, you have installed the Windows operating system. But note that the capacity of these virtual machines, if you sum the capacity of these virtual machines, which is less than equal to the capacity of the physical machine, right? Suppose I represent capacity of a virtual machine I. I'm representing this as a virtual machine 1, this is virtual machine 2, this is virtual machine 3. Okay. So if I take sum of I is equal to 1 to here 3, let it be n. So n is equal to 3 here because I have created three different virtual machines. If you see the capacity of this one is less than equal to the capacity of the physical machine, right? This is your physical machine. It will never exceed the capacity of the physical machine, right? So you can install different operating systems. It is not also limited to one operating system. Any operating system you can install in your virtual machines. And you can see in virtual machine 1, I'm running two different applications. In this particular virtual machine, I'm using one application. In these two virtual machine, I'm using another two type of applications. So VM technology allows multiple virtual machines to run in a single virtual machine. That technology, that's why this technology is much more popular. And before to the invention of the cloud computing, you can see this technology persists. But people have not utilized it properly. But in the case of cloud computing, we have seen that virtualization technique is properly utilized by creating multiple virtual machines and providing each and every machine to the individual user. Now, suppose a particular user U1 is using virtual machine 1. Let's say U2 is using virtual machine 2, U3 is using virtual machine 3. So the user is one is not aware that U2 is there in the system. So that type of abstraction is given in the virtual machine. Even if U2 is not aware of U3, they are not aware of also that the same hardware they are accessing directly or indirectly. Okay? So such type of abstraction is provided in the case of and so by the help of this virtualization technique. So if you look into performance, para virtualization is very close to the raw physical performance. So basically, there are three different type of virtualization. One is called as full virtualization. Another is called as partial virtualization. Third one is called as para virtualization. So we have three different type of virtualization. And these virtualizations are different from each other based on whether the hardware is supporting that type of virtualization or not. Full indicates that hardware is completely supported. Partial indicates that hardware is partially supported. Para indicates that the hardwares are not at all supported. Irrespective of that, you can go for different types of virtualization. Right? I'll tell you these details in subsequent classes. Now, coming to the advantages of virtual machine. What is the advantages? It is not the physical machine. It is a part of the physical machine. So obviously, you can say the utilization is increased, right? Let us see some other advantages mentioned in this slide. Run operating systems where the physical hardware is unavailable, right? Sometimes I told you, without a host operating system also, you can go for guest operating system. So you can run the operating system without thinking about the physical hardware. You can migrate this operating system or this virtual machine from one physical machine to another physical machine. Like you can see, suppose this is my physical machine 1. On top of that, you have created a virtual machine 1. There is another physical machine 2. You have decided that this virtual machine I will migrate to on top of this particular physical machine. That also you can do, right? So physical hardware is unavailable in the sense is that here you can see I am migrating VM1 from here under physical machine 1 to physical machine 2. That's why without physical hardware also you can do that one. And it is easier to and backup machines. If you want to take a copy of a machine, generally whenever you are creating a virtual machine, you are doing a lot of work. At the end of the process, you are going to destroy the virtual machine, right? So before destroying the virtual machine, if you want to take a backup of that particular machine, that also you can do. In fact, some also you can see some of the research areas also people use gives a instance, right, to their participant or workshops and the conference also they are giving some instances. So that instances are preloaded with some of the softwares which is required to write a particular code. So in that case, this is much more easier. Software testing using clean install of operating systems and software. Right? You can easily test whether a particular system works or not, right? So you can say whether it is operating system or any kind of software, you can easily test by the help of by the help of that whatever available in that particular virtual machine. You can emulate more machines than are physically available. Okay, like you have two physical machines, but you have more than two virtual machines. Okay, like here I can create 3 virtual machines, here I can create 2 virtual machines. So I can say I have 5 machines, but physically we have only 2 machines. Another advantage is you can see time share lightly loaded system on one host. So it is lightly loaded, it is not heavily loaded. If you go for a normal system, dumb terminal, or if you go for a dedicated system, we have lot of softwares. Like you see your laptop and desktop. There are so many softwares are there. It is fully loaded. But if you go for virtual machine, it is lightly loaded. And debugging also very easier, right? If there is any issues related to one virtual machine, you can easily debug because it is light load. But it is if it is having more load, then it is difficult to do that. You can suspend and resume the problem machines. For example, 5 virtual machines are working together and one virtual machine is not working properly. So you can suspend that particular virtual machine and resume with other machines, or you can add one more virtual machine. Migration of the virtual machine, as I already mentioned, it is virtual easier. Shutdown is not needed. So when you migrate this virtual machine 1 from physical machine 1 to physical machine 2, there is no need to shut down that particular virtual machine. Okay, that is also one of the advantages. And it also runs legacy system. Old traditional systems are also supported by the virtual machine. Next is you can see there is another concept that is called as cloud sourcing. So you may ask why this cloud sourcing is becoming important. Okay, or what may be the primary concerns related to the cloud sourcing. So let us see. Cloud sourcing is required because we need high scale and low cost provider. As a user, always our demand is that we will get the service with lower cost. If you go to a marketplace also, you are looking for a product with less price, right? In the similar one, we want the quality service with minimum cost. Right? That's why we need cloud sourcing. Any time place you need to access the services via your web browser. Right? If you have a web browser in your system, if you are connected to the internet, that is a sufficient requirement to use the cloud. Rapid scalability, you can increase and decrease, as I already mentioned. Incremental cost and load sharing. Today, initial cost is very low, right? If you want to add up more resources, gradually the cost is going to increase. And again, your company revenue is also going to increase, right? When you go for a startup company, initially you don't have cost. But when you run this company for 5 years, you have money, right? So you can increase more resources. Similarly, you can pay more to the cloud service provider. Load sharing is also one of the important aspect. Load should be shared among different type of server so that none of the server is overloaded. And it can forget the need to focus on local IT. When you go for local IT, the main problem is that maintenance. Handling different resources by your own is very difficult because day by day the softwares are changed, day by day the hardware is changed. Right? Like our mobile phone or you take our laptop and PCs. We are changing the laptop PCs over a period of time. Let it be 5 years to 10 years. After 5 years, the new processors are coming, new softwares are coming. Like today, we are not using Windows 7 or Windows XP machines, but we are using Windows 10 or Windows 11, right? So over a period of time, the software is changed and hardware is also changed. But when you go for your local infrastructure, you have to change these systems. Again, it is costly. But when you go for cloud, it becomes very easy for a user perspective. The provider has to change that, right? Some of the concerns related to the cloud sourcing is that first one is performance. We need 100% performance or close to 100% performance. That is really challenging. Reliability is one of the concerns. Service level agreement, SLA, standardization of SLA or maintaining SLA or drafting a SLA which is fulfilling the requirement of the user as well as provider is really a major concern. Controlling of the data and various service parameters is also another concern. Application features and choices. One application has several features, right? Sometimes you have opted for only two features. At a point of time, you can add up some new features, right? So your cost is also, that's why we say incremental cost. By adding more features, we have to pay more. Similarly, interaction between cloud providers. The major concern is that one service is provided by set of providers. Like if you want to purchase some product, the product is available in more than one place. So you have to decide from which place you are going to buy the product. So understanding the different provider, understanding the similar type of services is also one of the challenging tasks. And there is no standard APIs. The APIs used by a provider X is different from the APIs used by provider Y. So when you are habituated with a particular provider X, migrating to provider Y is becomes very difficult. So it is a mix of your service simple object access protocol and REST protocol, which you will study when we will go for service oriented architecture. In SOA, you will come detail about this SOAP and REST protocol. And always the concern is related to the privacy, security, compliance, trust, risk, reputation. These are always a concern. That's why even if you have come up with a plan to start to become a cloud service provider, suppose you have enough infrastructure to host as a cloud service provider, the challenging part is that what is your reputation, right? Your company is new to the market. People are very happy with you can say the popular providers, right? They trust the popular provider. They know the reputation of the provider. So in order to gain that thing for your new uh, a new provider is really the challenge. So for this you need actually cloud sources. Now we'll see about the cloud storage, because I told you if you go for Amazon Web Service, one of the popular service you will get, that is called as S3. That is called a simple storage service. Simple storage service. If you create a free account, you will get 5 GB of storage. You can store anything in this 5 GB, and you can share that data with your friends or anyone in the world. They can use that whatever link you have set, and they can download, they can view, and they can also just like they can download it, and they can also share the comments with you, personal comments they can also share. So just like Google Drive, we are sharing a particular file, right? So people, those who don't have access, also sometimes we are getting an email to provide the access to that particular file. In the similar fashion, uh, Amazon is also providing the simple storage service. Okay, so let us discuss more detail about the cloud storage. So several large web companies are now exploiting the fact that they have data storage capacity that can be hired out to others. So if you have sufficient data storage capacity, you can provide the data storage services to others. Like OneDrive is also one of the example. Right? You are using suppose MI phone. So MI phone is also providing you some storage. If you are using some mobile provider like Airtel and Jio, they are also providing some storage, free storage, 2 GB of storage or 5 GB of storage to you. You can store your data in that, right? So anyone can provide you the storage as a service, like other companies are also providing, and it allows data stored remotely to be temporarily cached on desktop computer, mobile phones, and other interlinked devices. Like Google Drive, if you take an example, if you look into Google Drive you can install in your system computer, you can install in your mobile phone, you can install in your laptop, right? And if you are using the same account in each and every device, and you have used desktop Google Drive, so anywhere you are modifying a particular document, it is synced to each and every device that is connected to the internet. That's why it says that whatever edit you are making, that is a temporary change. But if internet is there, the temporary change is going to be reflected in each and every location, right? Whether it is a mobile phone or desktop computer or any device, doesn't matter. Right? But make sure that internet is connected so that you can get the services. So I'll give you a demo on Amazon EC2 as well as Amazon S3 in later classes, so that you have more idea how actually this compute cloud and the storage works in the case of cloud computing. But before to that, I request you to create one account in AWS by providing your payment information. It is completely free. They will deduct a minimal amount, but the minimal amount is going to be refunded to you. Right? So no need to worry. And by that you can get the free services for 12 months. After 12 months, you have to pay for the service, right? That is the terms and condition. So you can create another email ID to use it. So another 12 months, there is no issue, right? But you should not use the service. Free trial service is expiring in 12 months. So after 12 months, if you do any kind of usage based on that, they are going to charge you. And now let us discuss about some of the advantages, as well as we discuss about the disadvantage of cloud computing. Because for each and every technology, you have to know both sides, pros and cons, right? You have to see plus and minus, right? But you can see that in cloud computing case, although there is some disadvantages there, but most of the companies nowadays, they are using the cloud. So you can say, in comparison to the disadvantage, there are more advantages. That's why people are using. Let us discuss one by one. Like computer cost is lower. Like whenever you are purchasing a particular computer system, you are asking your friends and relative to, or even if to the shop keeper, right, shop owner, that whether i5 processor is good or i7 processor is good or any other processors are available. Again, each and every processor is having a different generation. We are asking that, right? But there is no such requirement in the case of cloud. If a simple computer system is there, okay, where you can access to the cloud service provider, then that is sufficient. So the computer cost is not going to increase by the if you are interested, if you are willing to use the cloud. Right? You can see maybe after 10 years, all are connected to the cloud, right? Nobody is going to interested to know that what kind of processors are available in the market. So there is no need of a high-powered, high-priced computer to run cloud computing web-based application. It is web-based application. That's why your browser is important, right? And a minimal configuration is available, right? Like if you go for Pentium PCs or you go for core to dual core basis, right? There also you are comfortably browsing the web, right? In today's machines or workstations or the latest generations also you are able to access that particular web page. So there is actually no requirement of any high priced computer. And since applications run in the cloud, not on the desktop PC, your desktop PC does not need the processing power or hard disk space demanded by traditional desktop software. If you are running a particular program, suppose you have written a program and the output of the program you want to store in a particular file. So you can use Amazon EC2 for computation, and whatever result you are getting in this computation, that will be stored in Amazon S3. Okay, all the data are going to be pushed to Amazon S3. So that will be not pushed to your local drive. Suppose outcome of a particular program file is, let's say, 10 GB. You have written such a large program. If you run the program, the output file size is 10 GB. So you need not worry whether 10 GB space is there in your computer or not, because it is going to be stored in the Amazon S3 storage cloud, right? So as everything is maintained in the cloud, you need not bother about this processing power as well as hard disk space. And when you are using web-based application, your PCs are less expensive. The cost is also very low, and a small hard disk, less memory, or more efficient processor is not required. Very small devices also, smaller hard disks or less amount of RAM, like I mentioned, 512 MB or 1 GB of RAM is also sufficient to use the web-based application. In fact, your PC is in this scenario does not even need a CD and DVD drive. Okay, today's computer system also we don't have CD and DVD drive nowadays. We have pen drives, right? As no software program have to be loaded and no document files need to be saved. Earlier, what happened? Whenever you want to install the operating system or any particular software, these are used in a these are provided in the form of CD and DVDs, right? We purchase CD and DVDs from a software shop and we install in our computer system. Again, you want to write something, right? There also we are using CD and DVD. But as these operations are now not required, this is going to be maintained by the cloud. So you need not worry about the CD availability of CD and DVD devices, right? Now another advantages you can see that is called as improved performance. So utilization is very low in the previous case, right? If you go for legacy system or traditional system, you will say utilization is very low. But in the current system, the performance is improved. So with few large programs, which is hogging your computer's memory, you will see better performance from your PC. Okay. So performance can be increased if it is lightweight, right? Even if you have written a very large program, these programs are written in cloud or it is synced to the cloud. So we will see the better performance in our personal computer because we have very lightweight space, right? Or you can say small amount of space. A small amount of space, we can do a big things, right? That's why the performance is improved. And computers in a cloud computing system boot and run faster because they have fewer programs, processes loaded into the memory. Obviously, you can see when you have installed a new operating system, you imagine what is the speed, but you see the speed of your system now. Compare the speed when you install your operating system and current system. Obviously, you can find the difference. So when you create a virtual machine, the virtual machine is loaded with only the softwares that are required to you. Okay? No additional softwares are going to be provided to you. So obviously your performance is improved and it is lightweight. Next one is reduced software cost. As I said, the software, like if you go for Microsoft Office, you know Microsoft Office is not open source. Okay, so you have to purchase the license in order to use MS Office, right? So, but if you go for Google Spreadsheet or you go for Google Documents, here the software is free, right? You need not bother about whether your system is installed with Microsoft Office or not. Somebody is giving a particular file. If Microsoft Office is not there in your system, then you are not able to open it. But when you use this thing in cloud, like we are getting Google Spreadsheet and Google Docs, so you need not bother about whether your system is having Microsoft Office or not. So instead of purchasing these expensive software applications, you can get most of what you need for free of cost. Okay. So Google Documents is a live example of this reduced software cost, and it is also better than paying for similar commercial softwares. Like other softwares are also similar softwares are also we are using in our traditional system, right? So with cloud services, we can avoid such type of cost. That's why the cost is drastically reduced. Another advantages you can get here, that is instant software updates. Like in your system also, if you have a license to Windows version, so nowadays you are getting update of Windows 11. So frequently they are giving update that you can migrate to Windows 11. Right? So if you click to Windows 11, it will be loaded into your system, right? It will take some time. But if the same instance is available in you can say cloud, they have to take care of this thing, this update. So as a user, you need not bother about this one. That's why cloud computing. The advantages of this instant software update is that you are no longer faced with choosing between obsolete software and high upgraded cost. If there is an obsolete software in your system, you need not bother. If a upgrade also require higher cost, you need not bother. Right? Main thing will be done by your cloud service provider. So when the application is web based, updates happens automatically available the next time you log into the cloud. If some updates are new, right, it will be reflected in your next login, right? So you need not wait, right? When I am going to install Windows 11 in my system, I have to wait for some time, right? So, but if it is taken care by my cloud service provider, then I did not bother about this, right? So when you access a web-based application, you get the latest version without need to pay or download and update. You need not bother about it. Automatically, it will be done by your cloud service provider. Similarly, another advantage is improved document format compatibility. Like Microsoft Word case also. Suppose your system is installed with one version of Microsoft Word. My system is there with another version of Microsoft Word. When you exchange a particular document, sometimes there is a compatibility issues also there. Right? You may see some extra spaces are padded into your file. So you don't have to worry when you have such type of thing in cloud, because documents that you create on your machine being compatible with other users application and operating system. Compatibility issues not found in the case of cloud. There are less format incapabilities when everyone is saving the document and application in the cloud. Right? That is also one of the advantages. Now, unlimited storage capacity, a cloud service provider is having multiple data centers. They are located in various places. Even if the space existed, you assume that the space is existed in a particular data center, they can bring the resources from other data centers. They can redirect to another data center. That's why we can say cloud computing offers virtually unlimited storage. Like our computer systems, if you see, it is 1 terabyte, right? Once it is existed, then you can think of external hard drive or expanding 1 TB to 2 TB or 4 TB. But cloud case, this will be done automatically, right? Only you have to, earlier you are paying for 1 TB, not now you will pay for whatever extra space is added to your system. So your computer's current 1 terabyte hard drive is small compared to hundreds of petabytes available in the cloud. Okay. The requirement of an individual user is on TB only, but you can see petabyte or you can say zettabyte, yottabyte of things are available in the cloud, so they are unlimited. Next one is called is increased data reliability. Like if you go for desktop computing paradigm, okay, or a dumb terminal, the reliability is very low. But when you go for cloud system, we can increase the data reliability. Suppose in a particular in traditional computing system, if a hard disk is failed, then what happens? All the data associated in that hard disk is gone. Like in your system, if hard disk is failed, then you have to replace it, right? If it is not recovered. So some of the valuable informations or data, whatever there in the hard disk, that is gone. But in the case of cloud, there are sufficient backups are there. In fact, you can see the same copy is retained in more than one data center. If it is failed in one particular data center, crashed in one particular data center, then it can be retrieved from other data center also. So a computer crashing in the cloud should not affect the storage of your data. But when you are using your personal computer, there is a crash, all your data is gone. Okay. So that's why if the same data is available in the cloud, a Google Drive case you could take. Google Drive you are using in your computer system, Google Drive you are using in your mobile phone. Suppose your mobile phone is lost, then you need not worry. The same data is available in Google, right? Google Drive, the same data is there in the Google Drive. If your software, if your computer is crashed, right, or there is a hard drive crash, right, then also you need not worry because the one copy of the data is there in the cloud, which you can still access the cloud and you can download it. So in a world where few individual desktop PCs users backup their data on a regular basis, like early days people, what they are doing every week or every month or every day, based upon the sensitive data, they are taking backup. Okay, but such type of backups will be automatically taken care of by your cloud service provider. So cloud computing is a data set computing platform like Dropbox, OneDrive, SkyDrive, a lot of things we are using in the case of cloud computing. Similarly, universal information access, you can see that is also one of the advantages of the cloud. So that is not actually problem with the cloud computing because you don't take your documents with you. Whenever you are moving from one city to another city, you are not carrying your information, right? You are not carrying your data. You are not carrying any personal things, right? So just you need a computer system that is connected to internet, right, to access that one. So they stay in the cloud. These data are stay in the cloud, so you can access them whenever and wherever you have a computer system or any device that is connected to internet. And the documents are instantly available from wherever you are. It's subjected to your internet. If internet is there, then you can able to access, right? Somebody has updated a document. You want that updated document, that also you can get in the cloud. Similarly, another advantage is latest version availability. So when you edit a particular document at home, the edited version is what you see when you access the document at work. Like I mentioned, I'm using a computer system in my home, right? Another computer system at workplace. If I edited something in my home, if internet is connected to both the system, the same copy is available in the work. That also shows a universal information access. Whenever you are moving from your home to workplace or work to home place, you need not worry about carrying these documents in your pen drive, or you can say hard drive, external hard drive, or other versions. And always you have the latest version of your document, right? But make sure that internet is there. Sometimes if internet is not there or it is not properly synced, then you will get your old copy. So that also create a problem sometimes if the internet is not there or it is limited. So you are not in a danger of having any outdated version. Whatever updated versions are there, the same updated version will becomes available. Okay. Another two advantages is one is called as easier group collaboration, like multiple peoples. Like if you see our project, like especially you are doing also project in your final year. So a team consists of, let's say, 3 students. They want to do project combinedly. Okay, so what they can do, they can share the document. Okay, and they can edit a different part of the document. They can add more parts in the different section of the document at the same time. So for the better collaboration case also, you can use these documents. And many users do this sharing of the documents because it is important advantage of cloud computing, because multiple users can collaborate easily on document and projects. Like while writing the project report also, if you have divided different sections among your friends, then you can write multiple sections at the same time. And everyone will get an updated copy of that particular document, and there is no issue with respect to the latest version availability. The last advantages of cloud is called as device independence. That says you are no longer tethered to a single computer or network. You are not limited to one computer system, rather than you are open to any computer system. That is, changes in the computer, application, documents follow you to the cloud. Only you need your password, username to access the resources, right? Amazon, suppose I created one account in Amazon. Tomorrow I want to log in to that computer, the same thing in your computer system. That also possible, right? That's why we are not connected to only one computer. We are connected to any computer. And move to a portable device, your application and documents are still available. Any device, anyone's device, any location, you can access that particular device. So these are some of the advantages of cloud computing. So we'll stop here, and in the next class I'll tell you about the disadvantage as well as evolution of cloud computing. So if you